Okay guys, so in this video I'm going to be doing 4 problems from the study guide for the test, which will be tomorrow. Okay, and so in this problem, the first problem that I'm going to do is going to be proving that this shape is a rectangle. Sorry, it was supposed to say rectangle and it says square, but it's going to be proving that the shape is a rectangle. The very first thing I want to do, sorry, sometimes if I pause it's because I'm coughing and I'm muting myself. Okay, so very first thing I'm gonna do is gonna be finding the slope of all of these all of these 4 lines. Okay, in order to prove that the shape is a rectangle, I gotta prove a few things. First of all, I need to prove that the opposite sides, which would be these 2 sides, which are opposite, I need to prove these 2 sides are the same length. And these 2 sides that are opposite, I also need to prove that these two are also the same length. Okay, so I have to prove that our opposite sides have the same length. That's one thing I need to prove. The second thing I need to prove is that all the interior angles, this angle inside, and these two other angles inside, I need to prove that all these 4 angles are right angles. I'm going to begin with the angles because it's, I think, that one part of the most tedious part to do. Okay? Or actually, I could begin with the sides because I already have, as you guys can see, some marks over here of the lengths of these triangles that I'm making. Okay, so yeah, I can also do that. But no, let's do the slopes. I already have them. Okay, so let's begin right here. Right here, I stated that JG is perpendicular to IJ, but let's actually also prove this as well. Okay, so I'm just gonna go ahead and find the slope of all these sides. The very first one that you guys can see right here is the slope of JG. So J and G is there, so JG is going to be this side over here. And the slope, as you can see, it has a run of 1 and a rise of 1, 2, 3, and 4. So rise is 4 and run is 1, which can also be simplified to just 4. Okay, but that's the slope of JG. The next thing is the slope of IJ, and IJ is this length over this side over here. So the slope will be from this point I go down 3, so that's why it's negative, and then I go over 12, so that'll be positive 12 because it goes to the right, and I get a slope of negative 3 over 12, which simplifies to negative 1/4. Sorry. The next one is this other side up here, which is HG. And HG has again a slope. Well, this time it goes to the right, 12, which is positive, and then it goes down 3, which is negative. So again, it's also negative 3 over 12, which also simplifies to negative 1/4. That's the slope of this line. And finally, the last one is this side over here, IH, or HI, which has a rise of 4 and a run of 1, which simplifies to just 4. Okay, now that I have the list of all my slopes, I can see right here that, let me get some colors. I can see right here that a few of these, well, actually a few pairs of these are going to be perpendicular. If I take a look, in this case, I have JG. Okay, if I take a look at JG, that'll be this one. Okay, and IJ, that will be the second one. If you notice the slopes, well, actually, take a look at this one and this one. First of all, they're flipped. That's the reciprocal. And second of all, one of them is positive, the other one's negative. That's opposite. They're opposite signs. Okay? So therefore, these two are perpendicular because their slopes are opposite reciprocals. And that would be for this right angle. So that it's a right angle because these two slopes are perpendicular. So this is perpendicular to this. Okay? Not only that one, if I take a look at this one over here, ij would be perpendicular to ih. Okay, let's take a look at ij, which is this one, and ih, which is this one. Let's take a look at the slope over here, and the slope of this one, well, it's again this one. Again, notice they're flipped, which is reciprocals, and one of them is positive, the other one is negative, which means they have opposite signs. This is opposite reciprocals, so this one is also perpendicular. If we take a look now, look at IH, this one, and then take a look at HG, which is this one. All right, we want to focus on their slopes. Take a look at this slope versus this slope. Sorry, same thing. They're flipped, which is reciprocal. One of them is positive, the other one is negative. That's negative opposite reciprocals. So that's the case for that one. And finally, I don't think I have another color for this one. Do I? I do. The last one would be it's going to be HG and JG. This one on top. So take a look at this slope versus this slope. Again, opposite reciprocals. Okay, so there you go. All these are opposite reciprocals. Let me list all of them. I only listed the first two. The one in blue, that is IH, is perpendicular to HG. And the last one is HG, is perpendicular to JG. So that's it. We are done. This is true. Again, you want to explain why. Okay. Because opposite reciprocal slopes. I know this could be a lengthy problem, but it's just a process that has to be done. Okay, and that's just the angles now, all right? We still need, I'm not going to do number one. We still need to prove that all the sides are, well, that the opposite sides are the same length. Okay, now if I take a look at this one over here, you will notice that I get a triangle out of this part over here. Okay, where the length of this height, you guys can see that length right there is 3. And the length coming this way is 12. And the length of this segment, ij, we don't know. That's the one that we want to know. So I'm going to use the Pythagorean theorem. I'm going to call this side C. Why C? Doesn't matter. You can put whatever letter you want. But it's going to be 3 squared plus 12 squared equals C squared. So therefore, that's going to be 9 plus equals C squared. This is going to become 153 equals C squared. So then C equals the square root of 153. Alright, so this is the value of this length over here, the square root of 153. And you guys can put this in the calculator if you want, but you don't have to. Alright, now I will take a look at this side over here, and you guys can see that I get the exact same triangle out of this side on top. This length is 12, this length is 3, so therefore this length will be, again, the square root of 153, just as well. Alright, now if I take a look at this side over here, I get a triangle from here and here. The length right here it's 4, and the length right here at the bottom it's 1. So I get a triangle that looks something like this, with this length being 1, this length being 4, and this length being the length we're looking for. Let's call it B. Okay, that's length J G. So using the Pythagorean theorem, I'm going to get 4 squared plus 1 squared equals B squared, which is going to be 16 plus 1 equals B squared, which is going to be B squared equals 17. Therefore, B equals the square root of 17. And that's it. So this thing equals the square root of 17. And that is, this length over here is the square root of 17. If you leave it on the paper like this, I'll understand it. Okay, now if we take a look at this side over here, we get the exact same triangle because we get the exact same lengths. This length over here is 4. So we will get the exact same lengths. Alright, so right here I can see that you have listed all the lengths of each of the sides. Okay, if you list that on the shape, that's better. You don't have to write a statement. Okay, so we have proven that the opposite sides are the same length, and we have proven that all the angles are perpendicular because opposite reciprocals, slopes. Okay, and this is of course my proof that I have found the opposite, all the slopes. Okay, so on the test I will need to see all of these things. Okay, I need to see where you use the Pythagorean theorem to find the missing sides, where you found all the slopes, and where you listed the list of angles that are perpendicular. So that's this one. Sorry, I think it's the longest. Okay. The second one was this one. You guys wanted me to do a video on this one. So it's just a small explanation. The point 0, 0 is surrounded by several right triangles, all with a hypotenuse of 10 units in length. So pretty much, there is technically a triangle. Well, all of these are triangles, but they are right triangles. All of these triangles are supposed to be right triangles. Okay. So if you take a look, let's say at this right triangle, up and here, this side here is the hypotenuse of the triangle. And it says that all of these triangles have a hypotenuse of 10 units of length. So the distance from the center to this point for this triangle, from this point to this point, that's 10 units. How do you know that? Because this is the hypotenuse of the triangle. Same thing for this triangle in the middle. From the center to this point, that's the hypotenuse, which is also 10. So this length is also 10. Same thing for this triangle. From the center to that point, this is the hypotenuse. So this is also 10 units. And that's pretty much the same case for all of these triangles. The length from this point to this point is 10 units. The length from this point to this point is 10 units. Length from this point to this point is 10 units. And it's going to be the same thing for the triangles on the bottom and all the triangles over here. So explain why all of the vertices are just the points. Okay, this is a vertice, this is a vertice, this is another vertice. So explain why all the vertices of the right triangles that are not on the x-axis from a circle, so this is your x-axis, if you notice, this is another vertex of the triangle, but this vertex is on the x-axis. So you're looking for the only vertex that's not on the x-axis, and the only vertex not on the x-axis, well, it's these points. Okay, so explain why all of the vertices of the triangles that are not on the x-axis from a circle, so technically it's talking about these points, explain why all of these points make a circle. Well, the thing is, if I were to draw an infinite number of right triangles with the same hypotenuse, I will actually create a circle. Okay, because let's say I create a right triangle right here. There's my right angle, of course, and then of course I will connect that vertex not on the x-axis with the center. The question is, guess what's the length of this hypotenuse? Well, that length represents the radius of the circle. And the radius of the circle is the same everywhere. And if the length from here to here is 10, well, the length from here to the point that I created will also be 10. So any other right triangle that I make is going to add a point on my circle. And if I add an infinite number of triangles, okay, eventually all of these points will conjoin together to create a, well, the perfect shape of a circle. Eventually you'll have so many triangles in here, so many triangles that all the white spots will be covered, and you'll be left with a perfect circle. Okay, I will actually leave up to your guys' imagination how you guys want to answer this question. Just make sure you guys talk about the hypotenuse, and adding more triangles will pretty much create the shape of a circle, given that all the new triangles will have the same length of 10 for their hypotenuse. Okay, that is that one. You guys also wanted me to do question number 3. I'm gonna do this pretty fast because I know you guys don't want this video to be too long, and it's already 17 minutes long, 18 minutes long. Okay, this one over here. First, I'm just going to separate the x and the y's. There's a y, there's a y, so I'm going to put these together. So y squared plus 14y. Sorry, no, it's easier to put the x's first. Never mind. Let me put the x's first. X, x. So x squared minus 8x. I'm going to leave a little bit of space for my c value. And then I'm going to do the same thing for the y's. Okay, so plus y squared plus 14y. And again, I'm going to leave a little bit of space for my c value. That 3, of course, I'm going to take it to the other side. So adding 3 to both sides will give me, on this side, 12. Then I have this number, which will be the same here, and this number, which will be the same here on the other side. All right, let me find my c values. So for x, c equals negative 8 divided by 2 squared, which equals to negative 4 squared, which equals positive 16. So I'm going to add 16 here, and I'm going to add 16 here. Now do the same thing for this one. Equals 14 divided by 2 49. So I'm going to add 49 here, and I'm going to add 49 here as well. Now right here, two numbers are multiplied to 16 and add up to -8. That'll be x minus 4 times x minus 4. You notice -4 times -4 multiplied to +16. -4 plus -4 add up to -8. Well, same thing with the y's. Okay, two numbers that multiply to 49 and add up to 14. That'll be +7 plus 7. Again, 7 times 7, it's 49. 7 plus 7 is 14. And finally, on the other side, I have 16, 12, and 49. It's going to be 40, 50, 60, 75, 77. Now remember that if you multiply two identical things, they will combine to become just one thing squared. Plus two identical things, they will combine to become just one thing squared. And this side is just going to be 77. Now in this thing, we're actually asked to find the center and the radius. Well, the center is just going to be, remember, the opposite of this one, the opposite of this one. +4, comma, -7. There's my center. And my radius, this is an easy one, it's just going to be the square root of this, technically. Because it's not raised to the second power, it's going to be the square root of this. So in this case, it's going to be the square root of 77. Yeah, that's it. Okay, so that is this one. Let's do the next one. You guys asked me to do number 6, and let's do number 6. So the endpoints of the diameter are, these are endpoints of a diameter. I'm actually going to do all the steps, okay, as if it was, yeah, I'm going to do all the steps. First thing, I'm given the diameter. The diameter in a circle is just, what is just a straight line, right? This will be, let's say, the diameter of my circle. Let's say this will be the point 0, -8. And let's say this will be the other point 5, 0. Well, because these are the end points of the diameter. Remember, the diameter in a circle is the distance from one end of the circle to the other end. Okay. Now this diameter, the thing about the diameter is that it goes right through the center. And that center is located right in the middle of this diameter. So right in the middle, okay, that's going to be the center of my circle. The thing is, I'm trying to find that middle point. Okay, so how do I find the middle point? I'm going to use the midpoint formula, okay, which is going to be xm comma ym for midpoint is going to be located at x1 plus y2 divided by 2 comma y1 plus y2 divided by 2. That's it. So I'm just going to use this formula to find the middle. All right, so let me label my points. X1, y1, x2, y2. So the middle is going to be at, so x1, y2, sorry, x1, x2 is going to be 0 and 5. And I'm not changing the sign of anything, so it's just going to be 0 plus 5. It's going to be located at 0 plus 5. Don't forget divided by 2, comma, comma. Then it's going to be y1, y2. y1, y2. Again, I'm not changing the sign of anything. Everything is positive. So this is going to be negative 8 plus 0. Plus 0 divided by 2. That means that my center is located at, well, 5, because 0 plus 5 is 5. 5 divided by 2 is going to be 2.5. Negative 8 divided by 0, that's just negative 8. Negative 8 divided by 2, that's going to be negative 4. This is my center. So this center right here is the point 2.5, comma, negative 4. Sorry, that is the center. I forgot to mute myself. I'm sorry. Okay. That's my center. Okay. So I already have like half of the equation. The next thing is going to be to find the radius. Okay, now to find the radius, I have to find the distance. Well, the radius could be this one or could be this one. Either one. It's either the radius is going to be the distance from this point to this point, or the distance from this point to this point. And I'm just going to use the distance formula to find that actual distance. So let's see. Distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of that. Okay? So here's the thing. I have to choose. Do I want to find the distance from here to here or the distance from here to here? And this one already has the x1, y1. Okay? So I'm actually going to find this distance over here. I'm going to disregard this point totally now. Okay? Because I'm going to go from the center to here. So if this point is my x1, y1, then I'm going to make this will be my x2, y2. Okay? I'm just going to go here. This is going to be my x1, y1. This is going to be my x2, y2. All right? Let's put all these values into this formula. It's going to be the square root of x2, which is 2.5, minus x1, and x1, it's 0, so minus 0, squared, plus y2, which is negative 4, minus y1, which is negative 8. Now, if you notice, there's the minus from the equation, but then y1 is negative, so I'm going to have like a double negative. Anytime you have a double negative, that'll just make this thing a positive. And that's that. Begin by simplifying the things inside of each parenthesis. So 2.5 minus 0 is just going to be 2.5. Don't forget the squared. Plus negative 4 plus 8, that's going to be just positive 4. Don't forget the square. And then I'm just going to use my calculator to square each of these. It's going to be the square root of these two numbers squared. So give me 1 second. Bring up my calculator and square each of these numbers. If you guys are having trouble squaring values, which you shouldn't, here's one thing you can do. So 2.5 squared is just going to be 2.5 times 2.5. That's 2.5 squared, which is going to be 6.25. 6.25. So 2.5 squared is going to be 6.25 plus 4 squared. That's going to be 4 times 4, which is 16. So then the distance equals the square root of 22.25. This thing, okay, I can put it in the calculator if I want to. Okay, I'm not going to do that. Okay, this thing, this distance is my radius. This distance is my radius. So I'm gonna take this distance the way it is. Okay, I don't have to put it in the calculator. I'm gonna take it, and well, that's my radius. So my equation for this problem is going to be x minus 2.5, because this point is the center. Forget that. This is the center. Okay, squared plus y plus 4 squared equals, remember right here is the radius squared. And the radius is this thing. The radius is the square root of 2.25. But it's the radius raised to the second power. Sorry, now here's the nice thing about this, is that this thing actually simplifies. Because this, of course, and nothing is going to happen to this part over here. Okay, now this part over here, the squared cancels out with the square root, and you're just left with 22.25. So this is, give me guys 1 second. This is the equation. Sorry, this is the equation. This is your final solution of your circle. And that's it. Guys, I know the video is long and everything, but I have to explain everything. Hopefully this helps you. 30 minutes. It's ACDC.